In this section, we are going to learn about how Puppet works with container technologies and implementing orchestration in Puppet using Mcollective. We are going to look at how to install and configure Puppet server-side components in Docker containers and how to make the process as automated as possible. We will go through configuring and understanding each component first, and in the later videos, we will see how we can automate these processes using Puppet. We will then learn about the methods to run Puppet agent on containers and get the required catalogs from the Puppet server based on service roles. Next, we will learn how to create Docker images using Puppet, which is one of the most important tasks in the container ecosystem. We will then run an application stack on Docker using the respective Puppet modules. Finally, we will configure Mcollective to implement orchestration in Puppet. In this video, we will learn to run Puppet server-side components in Docker containers. First, we will learn about how containers and Puppet can coexist and provide an optimal solution for infrastructure management. We will also learn about the containerized method of running infrastructure services, including Puppet services. We will then install and configure Docker on our workstation. Next, we will learn to create a Dockerfile for the Puppet server containers and run the container successfully. Finally, we will run an entire Puppet server-side stack using Docker Compose. Let us first understand containers. Containers are entire runtime environments for applications, which includes all dependencies and system libraries required by the application. They have a minimalistic footprint with the least amount of packages installed, which makes them very lightweight as compared to physical or virtual machine operating systems. As compared to few gigabytes of operating system, most containers are tens or hundreds of megabytes in size. Containers can be run on a single operating system, and they share the kernel and other system resources. Containers are started from pre-configured images. If the images are not present on the base host, it takes some time to download them from the Docker registry. But if the image is already present on the host, then containers can be launched instantly. Docker is one of the largest and most popular software container platforms available today, with other providers existing such as CoreOS. Docker has been able to reach every corner of an organization with solutions ranging from developers to the enterprise production infrastructure. Docker and Puppet are both tools for infrastructure management. The tasks that are handled by Puppet using modules can be solved by Docker by using Docker files. Due to this reason, the concern is often raised about if Puppet and Docker need to coexist. It is believed by many that each of the tools are capable of solving problems independently without the help of the other. However, in complex infrastructure scenarios, both the tools can come in handy if architected correctly. Migrations from a native infrastructure to a container environment can be made very simple by use of Puppet and Docker. Complex infrastructures require complex infrastructures code logics, which can be better handled in Puppet modules than Docker files. Docker images created by use of Puppet modules can save the day. In case of hybrid infrastructures, the role of Puppet can be crucial in managing a common code base for a diverse infrastructure. We'll now quickly go through the ways in which a container environment is different from native operating systems. The Docker engine needs to be installed on the base host, and the Docker process needs to be running. By using the Docker binary, extensive management tasks can be performed on the entire Docker environment. Docker has its own set of terminologies such as containers, images, networks, registry, and many more. For complex scenarios, tools such as Docker Compose and Docker Swarm are available to create application stacks and clusters. By default, SSH access is unavailable on Docker containers. The Docker engine is able to communicate with the containers with subcommands such as logs, attach, exec, and copy being some of them. Although SSH can be configured on the containers, it is not recommended to do so. One of the most important facts to keep in mind is that running services is completely different in Docker containers. Services cannot be started or stopped by using service or systemctl commands. For this purpose, a process control system such as supervisor needs to be used. We'll now get down to some hands-on stuff. First, we will prepare our new CentOS machine called Docker host to run the Docker engine. We'll go to our browser and search for get Docker. We get the first link here. We'll go to the website for Docker. We'll get the Docker Community Edition. We'll click on the option to get Docker from the Docker store, and we'll go to the option for CentOS. And once we are there, we're going to copy the URL for the repo file. Once we are on the Docker host, we are going to go to the location etc yum.repos.d, and we are going to fetch the repo file. Once we are done, we are going to run the command yum install docker-ce. This is going to take some time. Once the Docker package has been installed, we are going to start the Docker service by running systemctl start docker. Once the service has been started, we'll quickly check this by running the ps command, and there we see the Docker process running. Now we'll quickly run a test container to see that our service is running fine. So we'll run the command docker run hello world. This will fetch a test container, and once we get a message similar to this which says hello from Docker, and it shows that your installation appears to be working correctly, this means that our Docker daemon is running fine and we are ready to go and do stuff with Docker. We'll now start with creating a Dockerfile for the Puppet server. To do this, we'll create a directory called Puppet server, and in this directory we'll create a file called Dockerfile, and we'll add some configurations. The first instruction tells Docker to use the base CentOS 7 image from DockerHub as a source image. We'll add all the new configurations in this image. Next, we have added a couple of run instructions to perform some actions, such as installing the yum repo information for the Puppet collections repository and the EPEL repository. We have then added instructions to install the Puppet server package and the supervisor process control system to run the Puppet server service. We have also added instruction to install the which command first, because this command is not available in the base image of CentOS, and it is required for the Puppet server package installation to complete successfully. We have then added a couple of add instructions to copy some files to the container from our base host. We will create these files later. We have then exposed the Puppet server port 8140 with the expose instruction, and finally we have added the cmd instruction to make sure that the supervisor process runs the Puppet server service. We'll now save this file, and we'll create the second file, which is supervisord.conf. We'll now add the supervisor configurations. Most of the configurations in the supervisord.conf file is generic. The configuration which is concerned with the Puppet server service is the last section called program::Puppet server. Here we are asking supervisor to run the Puppet server service in the foreground. We'll save this file, and we'll create the last file that is required, that is autosign.conf, and we'll just add a wildcard here. As we'll be working with Docker images quite a lot, we will now create a DockerHub account. DockerHub is a hosted Docker registry service where Docker images are stored and can be fetched from any location. We'll go to hub.docker.com and we'll create an account here. We'll choose a Docker ID. We'll call it extending Puppet. We'll provide the email address, and we'll choose a password. Once we have confirmed our email address, we can come back to the login screen for DockerHub, and here we can provide our Docker ID and our password, and now we are logged in to our DockerHub registry. Now that our Docker file and the respective files for Puppet server is created, we'll now create a Docker image. To do this, we'll run the docker build command. We'll provide a name for the image by providing the -d option, and we'll name it extending Puppet slash Puppet server, and then we'll put a dot, and there we see the image being created. This will take some time, so we'll be back when this is done. Now that the image has been created, we'll verify this with the docker image ls command, and there we see the CentOS base image has been fetched and our extending Puppet server image has been built. Now that our image is ready, we will run a container by using the Puppet server image. We have used the -p option here to map the 8140 port of the container to the 8140 port of the base host. If we don't use this option, then the 8140 port of the container will get mapped to a random port on the base host. We'll now run this command and see the output. Now we can see the container has been spawned and the Puppet server process has started. After some time, we can see that it says the Puppet server has successfully started and is now ready to handle requests. If we now go to a different terminal for the same host and run the docker ps command, there we will see our container is running with a unique ID. It's using the image that we had already created. It is running the supervisor command that we had configured in the cmd instruction, and it is in the up state, and it is mapping port 8140 of the container to the port 8140 of the base host. If we terminate the Docker process on our terminal, we'll see that the container is also terminated. We are not able to see the container in the Docker PS list anymore, but if we do a Docker PS-A, it says that it has already exited. If we want our container to run in the background, we can just add the -d option in the docker run command, which will run our container in the background. We can also add a couple of other options, such as name, which will add a name called Puppet server to the container in the Docker PS list, and we can also set the host name of the container, which will set the host name of the container as Puppet server. Once we run this, we see the unique ID of the Docker container. If we do a Docker PS, now we can see our container is already running. In this case, if we want to see the logs of the Puppet server, we can just copy the Docker ID and we can run the Docker logs and the ID, and there we'll be able to see the Puppet server logs that are being written. There are some very useful resources available in the Puppet community to get started with Puppet in containers. One of them is the Puppet in Docker GitHub repository. To find this, we'll search for Puppet in Docker, and there we have the GitHub repository. This repository contains Docker configurations for the various Puppet server and agent components. Another useful repository is the Puppet in Docker examples. We'll go to this repository and we'll copy the repository link. We'll now clone this repository on our Docker host by using the git clone command. Once this is done, we'll go to the repository and we'll go to the subdirectory compose. Docker Compose is the tool with which we can run multi-container applications. We need to create separate images for our application services and then create a YAML configuration for Docker Compose, where we define which containers will be launched using which images. Finally, with a single command, we can launch our multi-container environment. The Puppet in Docker examples repository has some pretty good examples of how to use Puppet components in different container tools. We will use the Compose example to launch a fully functioning Puppet server stack, complete with Puppet server, Puppet DB, Postgres for Puppet DB, and dashboards such as Puppet Explorer and Puppet Board. The docker-compose.yaml file is readily usable, but we will make few changes to the file before using it. We'll open the docker-compose.yaml file and we'll copy the container_name parameter and we'll add it to the Puppet DB section where it is missing. And we'll also do the same for Puppet Board and Puppet Explorer. We will also uncomment the environment and links parameters for the Puppet section. When Docker Compose creates the containers, it also creates a Docker network and adds the containers to this network. The containers can then communicate with each other using the container names that we have configured in the YAML file. The configuration also mounts some directories from the base host to the containers, which contain important files such as Puppet-specific configuration files, SSL keys, manifest, module, and Hira data. Next, we will install Docker Compose by running the pip install docker-compose command. Once Docker Compose has been installed, we'll run the docker-compose command with the up option. This will take quite some time, so we'll get back once this is done. Once Compose is done bringing up the containers, we can see a whole lot of logs from all the components. The images got fetched first, which took some time, and then all the services were started. Now that the containers are up and running, we can configure agents to communicate with the servers and receive their catalogs. Similar to the docker run command, if we want the process to be running in the background, we can add the -d option to the docker compose command. If we want to check the containers running, we can run the docker ps command in a different terminal, and there we see all the 5 containers are running with the ports mapped to random ports on the base host, as we have not defined a particular port mapping for them.